Anyway, so
okay. Let's
hold
kick
on.
off
Okay.
the RBNV for Tuesday, March 4th, 2025. Welcome everyone, and we got a queue going. Ray's up first. Go for it, Ray.
Okay. Anyway, so I was playing around with the OpenBot stuff again, and couldn't get things that look like they should work to work. And it's like you kind of think, okay, well, it must have been something that I did or forgot to do or didn't do right or something. Anyway, so they had a Discord channel, and I said, I kind of explained what was happening. And apparently all the revisions for the things that they showed in all their videos on their website hadn't been put in yet. So the videos were kind of actually ahead of the software in GitHub. Anyway, so he just said, well, those features haven't been incorporated yet, and he put out another revision to it, and now the things work. So, or at least some more of the things work. So it's like I wasted all that time thinking, of something I did. Anyway,
Ray,
so there's
thank you for leading the way.
What's that?
Thank you for leading the way.
Yeah. Anyway, so there's some neat things that you can do with it. One of the things I was hoping to get at more of the sensors in the phone. I don't know if they're all supported. I know it lists in the sensors in OpenBot Playground, which is uses the blocky code. It just lists the 3 axes of the magnetometer and the gyroscope. It doesn't list GPS or let's see, what else doesn't it list? Magnetometer. It doesn't list the magnetometer. It actually lists the accelerometer and the gyro, but no magnetometers axes. So I was a little disappointed in that, and then started to look at it's an Android app. Hold on a second here, if I can see it. It's MIT App Inventor. Oops. And started playing around with that. And that looks like it has access to just about everything that's in the phone.
And what is that? Oh, that's a phone app?
Yeah. It's apparently done by MIT.
It's like a block
App Inventor is
right?
what
a block environment.
Yeah, that's what it uses.
Yeah, they used it at my son's high school to teach a class.
Oh, they did? Yeah, well, that's pretty cool. So it sounds like you may know a lot about it, huh?
Well, I think it works well with Android phones. He has an iPhone, and it never works the way on the real phone, the way it looks on the screen in preview mode. So he's been running into issues with that.
Oh, okay. Yeah, it seems like
with an Android phone, you may have more luck.
Yeah, it seems like it works as it says, and I've been going through the tutorials, and so it looks like and that could be another setup thing, or maybe it's the gyroscope axes and the accelerometer axes were the first things that they supported, and maybe later on they'll support GPS, and I guess there's like a proximity sensor, there's a light sensor, there's obviously things that you can do with the camera, but the other thing too, I thought that the ESP32 would have access to those variables, but it doesn't seem like there's a way to get those to the ESP32. I guess it's going to require some more coding, but even with the blocky code, it didn't seem like that was the thing that you could do. So those kinds of things would have to stay on the phone. And I don't know. It's just seems like a little bit of a disadvantage there to have to do it that way. So, but
Yeah, it seems real surprising, Ray, that they left off GPS, because that seems like it would be the first one to implement what they're doing with it. Driving a car around.
yeah, so I was like, okay, so I don't know if it's still not a fully baked solution.
Yeah.
At this point, or they've got more work to do, or maybe this time I did screw up. Who knows? Maybe I'm not looking at things correctly. I've gone over, it's like you can enable, in the settings, you can enable all those things on the phone, independent of whatever app you're running. And there's the same sort of enables, that you can do in setup on the app, on the phone, on the OpenBot app. And so all those things are enabled, but you still, it doesn't show up as variables that you can look at with blocky code. So as far as the list of sensors, anyway, so the App Inventor looks pretty good. It seems pretty thorough. I don't know if there's going to be similar sorts of things there that don't work or aren't as documented or whatever, but yeah, I've just always been interested in it. Karim, I think, got into it several years ago. I don't know if the platforms are still using an Android phone for whatever groups he supports. It seems like it was that way a couple years ago. So I'm not certain what he's using, or if they still require like a phone as a controller, or those sorts of things.
Talking about here, Ray, is this still OpenBot or a different package?
Oh no, Karim. And the different groups that he supports. He had gotten into using an Android phone as a controller several years ago, and I think it was a requirement of one of the groups that he supported. So I kind of get the impression that he's been using an Android phone as a controller for, I don't know, maybe at least 3 or 4 years now.
Yeah, well, I guess it depends on what you mean by using as a controller. So, as an example, I played with a package that I thought was really good called Roborama, that lets you teleop and do and has a generic display, or generic set of widgets that can display output data and allow you to input variables like switches or teleop joysticks or such like. So it can be multiple things that can mean, right?
Yeah, that's true. Yeah, I guess he could be using it in several different modes, maybe not as extensively as I thought he would be.
But that's a different thing than OpenBot. So I guess I just missed the transition to controllers from OpenBot, where the phone is the robot controller.
Right. Yeah. Yeah, and I don't know specifically what he has been doing with Android phones on the robot platforms, but I was always trying to pick his brains. It's like, tell me what you know about that. But anyway, let's see. I don't know if I could show that. It's because it's runs on the phone. It's not like I can duplicate it, and it's not like I can point the phone at my camera and show it that well. I could give it a try. Turn on the power supplies. And connect to the robot. And I'm connecting the phone to the robot through Bluetooth. You can also, if the phone is actually sitting on the robot, you can connect it with USB. But yeah, okay, so the phone can see there's, nope, that never works that good, does it? Anyway, the phone can see there's a voltage divider to sense the battery voltage. There's a little sonar, rangefinder on it. It's got, front wheel odometry. It's got two indicators that they're kind of like turn signals. And the phone, what's on the phone can see all of those. Anyway, just the guy I was talking about.
Speak of,
Anyway.
I can't really say speak of the devil because it's Karim. Speak of Karim.
Let's see. There was another thing I wanted to show. Oh, yeah. Let's see if I still have the playground open. It's on one of these many tabs. Okay. All right. Load code. Oops, got to sign in. It timed out. Okay, got to upload the code. And got to scan the code. Anyway, so one of the things that, I don't know if you'll be able to see it. Of course not. Just like, whoops, I flipped the direction. And it looks like it stopped the app. Gotta get to the window again. I think I just killed the window that had it in it. Anyway, kind of under the screen, I accidentally hit the wrong tab. Anyway, underneath it's trying to scan a QR code, but on the bottom here, it would print out what the gyro reading was. But so at least, you can see it on the phone, but it doesn't look like I can get that over to the ESP32 and, play around with it or manipulate it on the ESP32. And that's kind of what I was hoping to do or wanted to do. But anyway, so that's all I have.
Okay. Trish, do you want to go next or should I go? Not hearing anything.
Maybe she stepped away.
I've got something to share, and I just got to figure out how to turn my camera around, turn my phone camera around. How would I do that? Anyone know how to turn the phone camera around when you're sharing on a cell phone?
Isn't there an icon that looks like a little camera that with like two arrows around it?
Yeah. What if you tap your video? Will it pop up?
No, I don't see it. Done. Well, kind of need for this to work?
You just turn the phone around.
Yeah, I can resort to that, I guess.
So you don't have a little teeny camera icon with like 2 arrows on it
No.
somewhere?
Okay. Let's see.
Oh, if on the bottom of the screen, if you click on camera or the video symbol,
Oh, yeah, yeah.
will it show it there? Will it give you the option for another
No.
camera?
No, it just turns it on and off.
Oh, okay.
Well, I guess I'll have to, let's see, all kinds of things you don't have, like, I can share the screen. Settings. No, it didn't work. Sorry. Should have tested this beforehand. Let's see if we can get this to work.
I wonder if you went to the camera and switched it there, if it would work.
Oh, support. No, the camera's already on, looking out the front, and I don't think that's what's sharing.
Yeah, Kareem, I had a question for you. What are you using MIT App Inventor on your, and to what
No.
extent do you use a phone to control your platforms?
When we use a phone, we program in Android Studio directly.
Oh, okay.
Yeah, we've done App Inventor stuff for teaching kids in the past, and there is some decent robotics integrations, but not sufficient to what we need.
So did you say you're using Android SDK?
Yeah.
I didn't hear
Android Studio.
Studio, yeah. Okay. So is that still a requirement to use the phone on the robot platforms do you use it as the main controller, or do you just use kind of all the sensors in the phone?
No, it's still a required component of the robot. So most of us use something called the Control Hub, which is produced by Rev, and it's actually it's an Android TV box with custom I/O and H bridges and servo drivers and things like that. So it's a custom integration of 2 different modules, but basically it's an Android OS. Phone type, quad processor, pretty standard that you'll see like on an Android TV device inside. But you can also just use a regular cell phone too. And in that case, you're connecting to usually something they call a Rev expansion hub, which you can connect to via USB, and it's the one that has all of the ports on it. So it can drive the bigger motors that we use, and has 6 servo ports and 4 analog and 6 digital and 4 separate I2C buses. that kind of stuff.
Hmm.
Because you always need some sort of actual thing that's driving the electronics on your robot, right? The phone itself can't do that.
Mm.
And so the different approaches to that. Another one that we did way back in the day, and I still have a box full of them somewhere, is I think it was called a yo-yo, IOIO, and a fellow produced it. It also basically gave you basic digital IO, analog, that kind of stuff, motor drivers, and it would just plug in over a OTG cable. So on the go.
Mm-hmm.
Man, sorry, we're still getting huge gusts down here, so the house is shaking. But
same thing
yeah,
here.
it's a good platform. Now the thing that you're using these days, I haven't figured out what the custom hardware interface is that actually lets you talk to motors and stuff like that. But the one you've been
Did you say
experimenting
you didn't
with,
know what I was using, or?
yeah, the one you're playing with.
Yeah, it's just the OpenBot platform. There's an app that runs on the cell phone, and they give you either it's Arduino code either for like a Nano, or you can do it for an ESP32. I did it for an ESP32. You can add, so the ESP32 looks at the battery voltage, and it'll cut off if it gets too low.
Yeah.
What else? It's got a sonar sensor hooked up to it. What else? I've got a TB6612 motor driver. I've got encoders on the motors, so it's reading the the encoder counts.
And that's a block lead type interface.
That's one way to do it. They have what they call OpenBot Playground, and you can look at some of the variables, but some of the more important ones like GPS, they're not showing up. So they did say that you should have, I think, at least an Android 11 phone. This one is an Android 9.
Yeah, I heard that last week.
Yeah, so don't know if that's it. My wife's and her phone is like an Android 14, so I could try it and see if other things show up. But so far, only the 3 axes of the gyro and the accelerometer are showing up, and no GPS.
When we do coding against like the sort of the built-in things like GPS and like the network stack on Android, that kind of stuff, we tend to stick with standard Android interfaces, and don't really worry about the custom, the robotics-oriented hardware so much. So, so like when we're doing GPS, we're using Android location services, that kind of stuff.
Oh, okay. So you're not really looking at sensors directly. You're getting information.
We're doing it through the Android operating system, right? It provides pretty full support for all of the stuff that's natively on the phone.
Okay.
Now, an off-board GPS would be a different standard. Off-phone GPS would be a different approach.
Mm-hmm. Okay. Many ways to skin a cat, I guess.
Yep. Did we lose Paul?
No. Can you guys hear me?
Yep.
Okay,
Yep.
so
We're seeing an empty chair, though.
What?
I'm seeing an empty chair.
Well, look at the other icons. There should be a picture of Roby the robot there.
Oh, right. Okay. Yeah, I see it.
So if you maximize that,
Yep, I got you.
David Ackley, this is for you, partly.
Yes.
Is he? So Mark and Doug and Mike and I got together at the makerspace and we resuscitated Roby. And so I'm going to just like do a little demo here. Little...
Is he going to twerk or something?
That would be a that
We
would
haven't
be
done
a
that far yet.
I think.
That would be quite the feat.
Are you seeing him move?
Yep.
Yes.
There's supposed to be a hand on that arm too.
Yeah, and so various of us ended up with various pieces of Roby. So Mike's got his head. Oh, there's Mark's got the other hand. I end up with the whole darn thing at my place, and replacing a few cables. But yeah, he's a pretty impressive robot, and I think with a little more work from several of us, he'll be in show condition again. So that's exciting to see.
Need to put him on a hoverboard.
There you go.
Lots of luck. Do you have the head with the Cylon eyes?
Yeah.
He's got the
Mike
the
has
eyes
the
are
head.
working.
Mhm.
So he's like an old man now. You operated on his knee, didn't you?
Yeah,
Give
yeah.
him
He's got
knee
a brand
replacement.
right. He's got a brand new knee.
I could use one of those.
I've got that installed in both legs.
I might ask you about that sometime. I'm looking forward to that sometime soon.
Oh God, you are.
Well,
a very-
actually, I found a surgeon that does it without cutting any muscles or any tendons.
Wow.
So anyway, there you go, David. I know you had a big part in getting Roby, helping design Roby, and happy to report that he's in quite good shape.
Oh, good.
That's all I had.
Looks like his backside may be exposed there. It's got
Oh,
something hanging out the back
yes.
there.
Yes. You might say his ass is hanging out.
Yeah.
Yeah.
So let's see. I'm just going to drop.
Oops.
Yep, he just dropped. Oh,
Come back to here and
you didn't show off the fancy transportation system that we made for it.
the fancy which system?
Transportation system.
Oh, yeah, all right.
Oh, yeah, in the garage.
Suitcases.
Yeah.
Let's see. I've got something to share. It is okay. So a few pictures. So yes, this is torso. Are you guys seeing his torso?
Yep.
Yep.
And so that's what his arm looks like. This is the non-articulated arm with the spinning wrist, and that's the articulated arm with the torso in the background. And again, the articulated arm and his head, his back, electronics. Okay, there's all us guys. Oh, there's Mike about to use a circular saw to cut a slot for his neck in a suitcase.
Yeah, he worked wonders.
Okay, and then I'm going to stop sharing that and share.
Sounds like that might have been a dangerous move. You went out a suitcase with a circular saw, Mike.
Well, we held him back and stopped him in time. Let's see. Here we go. So, are you all seeing? Yeah, you're all seeing the YouTube video, right? Little video of him with his head assembled and all his hands on and doing his thing in the makerspace.
That's very impressive.
Yeah. And we did have his head looking left, right, up and down as well, just not in the video. It was
There
good.
you go. So that's all I had.
It's a gold star. I mean, yeah.
So good work by Mark, Mike, and Doug
And yourself.
and myself putting it all together. And
Yeah, we
were somewhat
added files. We added files to GitHub.
Yep.
Yep. And I've been in touch with Jason. He's found some of the software, I think, but he's still looking for some other parts of it. So hopefully we'll have Roby back in shape here pretty shortly.
What processor is he using to control everything?
Arduino Mega.
Ah, he's new enough to be using an Arduino.
Yeah, it's the Arduino drives several motor drivers, and he's a kind of a 6 degree of freedom, maybe 4, maybe 6. Two of them aren't really. There's 4. There's 2 servos for his, one for rotating his shoulder and one for flexing his shoulder, and then 2 for his neck, and tilt and yaw. And then there's a servo that just runs continuous. It's a servo tester that just runs continuously to make one of the hands work. So yeah, it was fun.
That's cool. Great job, guys.
Thanks. Let's see, is Trish back on? I saw her.
Yeah,
Okay,
she dropped off.
she probably had stuff to do. Dave Ackley had something.
Yeah, I just had a quick item. This last weekend, I celebrated my 6th wedding anniversary, 6-month wedding anniversary.
Wow! Congratulations.
That's all
Nice.
I had.
Well, that's a lot. That's great.
Yeah. And then Mike.
Okay. Well, I resurrected. I'm creating a new version of my robot for this Roborama, and so I've been picking all the pieces off of my old robot. So you can see here that the platform is pretty empty now, and I created I have a new wooden platform. It's bigger than my 3D printer could print, so that's good. And I've taped down the electronics on the top, and on the bottom is the battery and the 2 motors, two wheels, and then I went to a caster wheel this time, so it should be pretty typical. And I'll be adding all the other sensors on it. Right now I'm just trying to get it to do teleoperate, just to run. And so I just used the code from last year as is, even with all the sensors taken off, and you can see it on the ground here. And I have a remote, and it still works. So that's where I'm at right now.
And you probably saved 25% on the plywood because, you know, I'm sure that probably came from Canada, right? So
Probably, yeah. and a lot from China too. So the Chinese
oh, you
part.
think it's Chinese? Yeah, who knows where it came from?
Yeah. And yeah, so I've been working. I built all the little pieces to it. Also, I have the see where are they? Yeah. So I have created a new module or new system here where I have the lidar on the top and a camera, the same camera, but the lidar is new, and I also have the IMU mounted here, and I'm going to add. I've redesigned the time of flight sensors so that I can do obstacle detection. I'm using the lidar only to detect the arena, the walls in the arena. Just it's above the cans, so it doesn't see the cans, and the cans don't obstruct it. So I can always have a pretty good reading. And these will be seeing all the obstructions, and the camera will see the can, and then these will sort of home in on the can, just basically the way it was last year. And let me see if I can. I should have brought this up. It takes a while for my CAD to come up, but I've been designing it all in CAD, just designing the sensors, like the location and the direction and stuff to get things to work. And I also have a new way to grab the can. It's going to have two clamps that'll grab the can, and then it's going to have some limit switches to know when it's pulled it into its receiving thing, and then I have the file here. I'm going to pull it up, and I'm going to share this. Let's see, so I'm going to go to my. Got to figure it. Okay, share. Okay, so this is my robot here, and so you can see here, I have the wheels, and then the electronic modules where they're going to go, and then the tower I showed you that has the camera and the lidar and the IMU, and I have a laser pointer. This is the mount for the laser pointer, and it's all printed up and made, so it's ready to install. And so basically on that platform, I've mounted everything except for the sensors. I just wanted to get the mechanics, the drive chain to work. So you can see here the limit switches I'm going to put on there, and these operate independently with the servo motor. You can see a servo motor down there, and it'll pull the can in. So if I turn the can on, so it pulls it. So basically, I have a full size, an accurate sizing of everything, so that I know that it's going to grab the can right. It's not going to jam up or anything. And this is the interesting thing here. This is my sensors, the time of flight sensors. And so you can see that I have 4 obstacle detection sensors that'll basically be able to see 160 degrees or something And these are the 8x8 sensors, so I'll have a really good range, a field of view. And I can add it to the navigation system to use it for obstacle detection. And then if I put and then this right here, this one sensor here is just a single point time of flight sensor. And all that's used for is to locate the can distance and pull it in, to be able to pull the can in. So if I put the can on and rotate this around a little. Yeah, so you can see that like when the can is out here, these sensors will detect it and it'll basically say left, right, to try to get it aimed straight at it. And then once it comes in far enough that these don't detect it, then I'll use this sensor to pull it in all the way. And then the limit switches, these things that are right here, like this limit switch, I'm going to make it so that when I close the gripper, it'll close, and when this limit switch gets set, then this gripper will stop. When this limit gets set, this gripper will stop. So it'll pull it in and align it properly. So it should work really well. And oops, let me go to a known view. And then this says the where's the lidar range? Yeah. So that's the lidar. So basically it doesn't see the can, but it'll see the walls. So it's going to be my main odometry is just seeing the walls, where it's located, so that I always have good position and heading using the navigator. And the walls I'll have predetermined with I'm not using SLAM, it's just a map of the walls. Since it's a known size, you can do that easy. And so I'm going to take that guy out because it just obscures everything. And then I have the camera cone, which goes in there and sees everything. And if you look at it from the right side, let's turn off the time of flight cones. Where are they? No, I can just do this, I think. There we go. And so you can see here that it's looking over the can here. And so when it pulls a can in, it can still see the other cans. So it could do some processing of figuring out where the next cans are. But its main thing is to locate a can and then use the time of flights to get the and do a distance estimation, and then pull it in. So it's basically what I did last year, but I think I have a much better, more solid design. So that's sort of my show and tell.
Mike, are the field of view of those time of flight sensors really as wide as you show, or is that like an 8x8 sensor?
It's okay. Let me clean it up a little. Where's my sensors? Got so many components on here. Oh, there they are. Okay, so I have them round, but they're actually that wide. But they're actually squares.
Is that one of those 8x8 sensors that you used last year?
Yes, they're 8x8, and it's a rectangular field of view, not a round.
Right. Yeah, I get that. Yeah, thanks. I was wondering. I knew they were lidar, and I was like, surely that's not a single beam lidar. And it's
Right,
not.
right. Yeah,
Yeah.
this one is here. It's a single
Right.
beam.
Right.
Right. But these are 8x8. So I have a nice wide. Last year I only had 3. This year I'm having 4. So I'm going to be able to see obstacles and avoid them so that I don't run into cans when I'm trying to take it to the goal.
Cool.
Well, that's my show and tell, and I got the drivetrain to working, and now I'm trying to figure out how to I'm trying to create a new software environment and pull in the stuff and use ROS a little bit than I did last time.
Nice.
But one thing I did do is it was like 6 months or 8 months since I fired up my Linux on the Pi 4, which is on the robot. And of course, I tried it and said, okay, the ROS still works and it moved using the remote. And then I did an update and an upgrade, and ROS still worked, but VS Code won't connect now. It connected before I did the update, but now it won't connect. So what in the world is going on now?
Not one thing, it's another.
So something on my updates and upgrade of my Linux system caused VS Code remote not to connect to the Pi, to the code on the Pi.
Just say, well, don't do that then.
I've already done it.
You can't unupgrade it, or
Yeah,
go
I guess
back
if I was smart, I would have kept an image of the drive. All right, thanks.
Thanks, Mike. So I think we're at open mic now, and I have a question for Chris. Chris, you I think it was maybe early last year, or maybe late the year before, you showed a demo of, you had a ROS 2 robot running the navigation stack, and it was running around a circle of boxes in your office. Do you know what I'm talking about?
So, yes. Now, it wasn't running. Let me think. I don't think I was running the ROS navigation stack, and I don't think it was using ROS 2. I haven't upgraded to ROS 2 yet. What that was doing, navigating around the boxes on the floor, it was using what I call David Anderson keep it simple type navigation, because I wanted to try that out. I was using ROS, but I wasn't using the navigation stack. Okay, so I was using other parts of ROS. I was using, RViz to visualize everything and all that stuff. I was using, the lidar and all that, but the navigation logic was just, more straightforwardly implemented.
Okay, thanks, Don. I had hoped you'd be able to give me the answer to my question, because I'm struggling a bit with that ROS robot that I showed last week, Minibot, with the ROS navigation stack, and it's losing localization with the lidar when it spins quickly.
Oh, okay. I can tell you on that. Yeah, so that is part of the reason why I gave up on the ROS navigation stack, and that's part of the reason why a couple of years ago I spent a lot of time actually trying to compensate for what happens when you spin, right? Because you have a low-end lidar, and some of the lower-end ones, they spin only somewhere between 5 hertz and 10 hertz.
Yeah.
The more expensive ones spin a little faster. Like I have an RP lidar A2 now, which is like a middle of the tier. I think you can spin it at up to 15 hertz before at least my robot starts to shake because it just doesn't have a lot of mass. So the faster you spin, the less of a problem that is. But what happens is when your robot moves, and it's more of a problem when it rotates, right? The lidar spins at a finite speed. So it's almost like you're taking the picture, you're moving the camera. So it's not so much a blur. It's just kind of the whole,
A distortion, yeah.
It's a distortion of sorts, and you have to compensate for it. And allegedly there's a way in RAWs you can do that. That feature just didn't seem to do anything. I forgot what it's called. I can look it up and email you later. But there is a sort of something built into RAWs, didn't work. I came up with my own lidar de-warping logic, right? That uses odometry and the IMU to sort of tell me between two time intervals, how much has the robot actually moved, and then kind of interpolates, and basically it takes each lidar point, right? If you think about slow motion, the lidar takes some 300 or 360 samples, and I take each one of those samples and say, where exactly was the robot when this sample was taken, and which way was it facing, right? And then I kind of manipulate the lidar data before I actually then use it. It was working to a point. I was making things better, but it wasn't working as well as I was hoping. It just, the faster I went, the faster I turned. The navigation stack was still getting confused, and I forgot what I was using at the time. There you have a couple of options there, and anytime I turned, it would just still get confused. So what I then ended up doing is I ran the lidar through a simple kind of gate filter. And if I know that I'm turning too fast beyond a certain number of degrees per second, I just kind of shut the lidar off. I don't even pass the data on to the navigation stack because I knew it was just going to get confused. So it was better not to give it any data for like 2 seconds while I'm turning real fast, right? Then give it the data continuously, but let it be completely confused by it. So that worked to a point and made things better. But then that's when I then at some point sort of decided, okay, let me try to keep it simple, stupid approach, and don't use the navigation stack at all. And sort of I put that on the shelf. I can send out a link to my lidar de-warping repository in GitHub. There's a couple pictures there. You can see how it's before and after. Like I said, it's not cleaning it up as well as I was hoping. There's probably just some calibration needed, right? Because if there's dynamics involved that I'm probably not fully appreciating, and so my math is probably okay, but it's still not able to filter out all that distortion.
Chris, it sounds like your compensation logic was quite compute intensive.
It was. I was doing it in Python, and that turned out to be, it turned out to be quite intensive. I mean, if you did it in C or C++, I don't think it's not that much number crunching that's happening. But if you do it in Python and you don't do it really efficiently, then yes, it was bogging down the pie quite a bit.
So you were on a Raspberry Pi when you were running this?
Yeah.
I guess the KISS solution would be to stop it for one rotation of the lidar, do the scan, and then move on, do the next scan.
That's an interesting idea, to turn the lidar off. I mean, shut off the data feed for a little bit. That's interesting.
Yeah. It was working better than feeding it data that it can't handle.
Yeah. Last year I didn't use the stack. I did my own stack, I guess, or my own navigation. And when I was aligning with the walls and understanding where I was using my time of flight sensors, I had to sort of do it when I was stopped. And then, so I stopped a lot. And in this game, you sort of stop a lot. So, but when I was moving, things got a little crazy. Yeah.
Well, thanks for that insight, Chris.
Yep. Yeah, that's why then I spent more money. And I started out with the repurposed, robot vacuum kind of. The first time those came out, right? I mean, it was going at 5 hertz, 7 hertz max, and the A1, the RP lidar A2 goes twice as fast. Some of the newer ones, I mean, the lidar stuff now for probably $100, you can probably get something that's even faster. So the faster you spin, the less of a problem it is.
What, Paul? You had we were talking about a lidar that you just got recently, right? What does that spin at?
Yeah, that's the LD19 lidar, and it spins at 10 hertz.
Yeah, 10 hertz is it's on the lower side. Yeah, you want more than that.
Okay. Maybe I'll just like limit the rotation rate.
Yeah, could do that too. Yeah, and it's really mostly rotation. I mean, if you're just going in the straight line real fast, you still see the effect, but it's nowhere near as damaging to the logic.
Hmm.
Yeah, I was going to say not only spinning but moving forward. If you're moving fast enough, you're scanning clockwise. The first ones are going to be a lot further back than the latter ones. So
exactly,
you're still going to get distortion.
But it's not as bad. It doesn't. It's. I mean, you can see it. How it impacts the map building. If you're doing some flavor of slam. If you're just going straight, you can see the map's not immediately getting all messed up. But the moment you rotate it a little, it starts putting stuff in the map that's just not there, and it becomes a complete mess, and it just becomes unusable.
Right. So throw that away and start mapping again.
No, it's interesting that we're talking about distortion effects with a moving robot that's not actually moving that fast. Where does this take us in terms of volume-based mapping in high-speed vehicles? Do auto-driving cars not use lidar at all?
Oh no, they do, but I thought they rotated a lot faster.
A lot faster.
Okay.
And again, you can compensate for it with the right math and with everything carefully calibrated, right? If you really understand exactly how your lidar works and where it's pointing at what point in time, and where's the robot at that point in time, and what is its pose. If you have all the right parameters, it's just a bunch of geometry. I mean, my head was exploding with all that geometry, but it was a good exercise. I hate math, but it was a good exercise.
It makes an argument for solid state lidars. Bob Cook was demonstrating one that he bought this past weekend, which is very fast and very accurate for $50 Canadian.
Wow.
Yeah,
Really?
bought it at Robot Shop. Single line, about 100-degree field of view, and it works really, really well.
Wow.
I had a really cheap solution. I have a laser with a line lens, and I can look at it with a camera, and that's could be up to 40 frames per second. So with a reduced image, because it's TMI, you don't need that many pixels to figure out where an opening is or that kind of stuff. So
Tom, do you have a link to that lidar that Bob showed?
I don't offhand, although I can probably find it quick and post it.
Yeah.
I'll take a minute to look.
Thank you.
Yeah, I'm going to try to use Navigation Stack this year, and I'm hearing all this, and it's like, ooh, sounds like it's always tough. Okay. Oh, Chris, did you do simulation and real world or just real world? Did you try to simulate your robot?
So that particular one, my latest one, which frankly I haven't fired up in a while. So this one, let's see, is it in focus? Yeah, so this one I don't have a simulation environment and model for. The one where I used simulation extensively, both for the environment and the robot, was a couple years earlier for the Trinity firefighting competition that they no longer have, which is local to here where I'm living in Connecticut. And so yeah, the simulation, the way I was using it is I was making sure I do everything in such a way that I can run my logic on the real robot and on the simulated robot. And
Yes. I was wondering about navigation stack. Did it, or the lidars and stuff?
so,
to-
okay, so that again, it predates me using lidar. All right. Well, it overlapped a little bit. I started to try to figure out how to use the lidar, how to simulate the lidar. But what I quickly learned was the simulated lidars, they were all perfect. Okay. They were taking an instantaneous sort of 360-degree snapshot, right? So there was no distortion. Right, so I couldn't, and I was trying to find a way. Okay, how do I simulate that effect? And I at some point had to shelve it. Right, you can do things like simulate a spinning lidar, but just taking 360 or so individual range scans with whatever the simulation environment gives you for a simulated sort of distance sensor. I was doing that. That was bogging the simulation down too much, so I couldn't quite replicate those imperfections of the lidar, right? With other sensors, it was a little easier in simulation, right? You always are given a perfect sensor, and then you model some noise on top of it, you know. But with ultrasonic, you kind of know how it behaves. You can do some things there. The IR, the sharp IR that I had modeled, you know, again, you know, once you get too close, you won't get a reading and all that stuff. And then you can add some noise. All of that's straightforward. But with the lidar, you know, that whole distortion, the simulators just did not give me that, and there wasn't an easy way to replicate it. And then you know, and at that point, right? I mean, it's a simulation. You have to make sure you're not trying too hard to make the simulation match your real robot exactly. You're just going to spend a lot of time on the simulation, but you have to be close enough for it to be useful, right? And when something like the lidar and the distortion and how it impacts everything has a big impact, right? You do want to simulate that lidar accurately, otherwise it's just not going to be useful, right? It's going to just work perfectly in simulation, and what's the point of that?
Right. Yeah. I was wondering if that's a good place to debug this lidar, but guess not.
Now it could be, right? Again, it could have been. It's just that I didn't have a way of simulating that effect.
Yeah, simulating the distortion. Yeah.
Yeah.
Or the real world. Yeah. Okay. Thanks.
I think you make a good point, Chris, though, about simulation fidelity and what your goals really appropriately should be for simulating. So when at one point when I was working on the self-driving trucks, I was in leading the simulation, software simulation, and then hardware in the loop simulation projects. And really the goal there was more at a smoke test level. It was not to model with high fidelity the dynamics of the vehicle and its exact trajectory and such. Yeah. And there's a lot of value in that, in just that. And then debugging the once you've got the basics working, then debugging the rest of it on the actual robot.
Exactly. Yeah, that's exactly how I approached it for that competition. I had like a 2 meter by 2 meter arena, like a maze of sorts, and I had a real setup in the basement. But again, it just was time consuming, and there's just so many little issues in the code, right? You're chasing so many stupid errors, and then I just in the end said, okay, now there's got to be a better way. yeah, I didn't want to. I didn't expect the dynamics to be perfect, and I didn't even try to model all the inertia and the torque of the motors and the mass of the robot. I dabbled a little bit, but I didn't really want to get hung up on it. And it was good enough. And one of the reasons it was good enough, and I probably mentioned it before, is luckily I had good enough motors. It had enough torque, so that on my real robot, when I tell it to go at speed X, right, it went at speed X. I tell it to accelerate at some rate. It did that faithfully, right? And so in the simulation, again, there wasn't a lot to be done to simulate, complicated dynamics. I just didn't have, luckily, very complicated dynamics with a small, mass sort of robot. But there's a lot of value in fine tuning the logic in all kinds of corner cases that were deliberately, set in the real arena. There were mirrors on the wall to confuse your IR sensors, right? That kind of stuff. So I simulated all that. I put up certain objects. There wasn't really a way to do ray tracing. I mean, nowadays there probably is, but so you can do things like, okay, I know my sensor is hitting this object, which I have designated as a mirror. All right, I'm gonna just throw this reading away, right? So simple ways you can make sure your logic doesn't get instantly confused by the fact there's a mirror, and now for half a second, you're not getting any readings back from one of the sensors. You can debug all of that logic, right, in the simulation environment. That's how I used it pretty successfully.
Yeah, and if you like, I did kind of a similar thing with at an even more rudimentary level for Robo Columbus, where I just used, there's a TurtleBot simulator in ROS, which is just about as basic as you can get, but it's enough to debug things like when you want to rotate 90 degrees and you're going past, rolling around from 360 to 0, stuff like that is will just eat your lunch if you're doing it on a real robot, because it's so hard to repeat and to set it up to be exactly right. And so you just need to choose appropriate goals and then an appropriate level of simulation.
Yeah. So all of that simulation work I did, that was pre-ROS. Once I put that on the shelf, that's when I got into ROS. So that was all pre-ROS, all on a 8-bit micro. You can get a lot done on an 8-bit micro Arduino type platform from Pololu. So I haven't done the simulation in the context of ROS.
Yeah. Okay. Yeah. Thanks. Well,
I think that little camera is, or solid state lidar or whatever it's called. I think it's kind of the same setup that I'm doing. It's like looks like it's got a Fresnel lens on the front of it, and it has 2 cameras or 2 sensors instead of 1. So,
yeah, the major issue for general use is its very limited range. Those ones
only
30
like
centimeters, and that's all.
A foot, yeah, roughly a foot.
Yeah.
Now I don't know how well they work beyond that. When Bob was demonstrating it, he was just using a pre-canned demonstration that comes with the device itself. So he hasn't explored its limits, and one of those that he wants to explore is the range. Is it stuck at 30 centimeters? What happens when you go beyond that? He doesn't know yet.
Huh. Interesting. Thanks for that, Tom.
Well, Bob sees some interesting possibilities for it, certainly for close-in work.
Oh, okay. Oh.
Yeah, the little laser setup that I had. Of course, it is a 50 milliwatt laser, but it'll do like 10 feet, so which is good enough for the 6-can course.
50 milliwatts, eh? A bit of a safety issue there.
Yep.
I can talk a little bit about the progress I've made so far on my line following gadget, if you like.
Yeah.
Yeah.
A little bit of progress. Let's show the right picture here. I mentioned this very briefly last week that I was working on this, so I have a few better pictures perhaps. You can see what I'm displaying.
Yep.
So I took a couple of pictures to show better than holding it up and waving it in front of my camera. This is the old chalk tracker toy, which I've modified and added stuff to. It looks very impressive. I should point out that these beautiful looking rear wheels are just decorative. They actually don't touch the ground. There's a caster underneath the chassis. Really looks nice.
All for show, huh?
These little ones in the front, those are the drive wheels. So it's a differential drive robot. Very straightforward. And I've added the bits and pieces to the top onto a piece of plywood, which I like working with. Easy to add stuff to a piece of plywood, right, Mike? This is the micro I've chosen to use, a 2866, an ESP 2866. I'll talk some more about that in a minute. It's on an expansion module, and I've chosen to simply use these modified ribbon cables from my junk box to bring the signals out from the expansion connectors out to this basically switchboard, this perf board, which makes it a bit easier to hook up to stuff. Every time I build something, I add displays and push buttons and LEDs. So I've mentioned that I have built a bunch of these standard I2C interface devices to make it easy to plug in a bit of local I/O on a robot. So that's what this is. This is my first application of the standardized one, and it's working out well. This thing has a 2S lithium-ion battery on it, and because I had one, I stuck an ultrasonic detector on the front because it just looked neat. A little closer look at the front. This is the very front of this thing. This is the module that contains the line sensing devices. It sits very close to the floor. The printed circuit board contains logic for 10 infrared LED and sensor pairs. 8 of them are installed. You can see out of this set of 5, the outer 4 are actually implemented in this device, which is part of what came with the original chalk tracker toy. The middle 2 are not in place. The logic that's on this board then takes each adjacent pair of infrared sensors and ORs them together, sums them together electronically, runs them through a simple differentiator, a capacitor that forms a high-pass filter, runs it through a gain of 10 op-amp, and out comes 4 analog signals, which are high-pass limited. There's about a 1 millisecond time constant on these things. All 8 of the infrared LEDs are all switched together with a power transistor, which the computer can control, and must control, obviously, or you wouldn't see much. I mentioned it's a differential drive. Let's see, that's about all there is to show in this picture. So that's the heart of the thing. That's what the sensors will look like. My research into how line trackers normally work indicates that this is probably a poor implementation. I don't know how the original toy designers arrived at it. Perhaps not very rigorously. We'll see how it works. I'm going to go with that.
How wide is that, Tom?
How wide is it?
Yeah.
Good question. The distance from the innermost pairs of infrared sensors, this one here and this one here, is 3.5 centimeters. A strip of black electrical tape, of course, is 2 centimeters wide. So that makes for a sloppy sensor for the center point to start with.
Yeah.
And the distance from the outer one to this one would be about 8 centimeters.
So yeah, that's why I was getting at. Those outer ones aren't going to do you much good.
Well, only when you're attempting to detect things like an intersection that has acute angles on it. Okay. Then there might be a little tiny bit of value to that. But I'm not very worried about attempting to make this thing track really sophisticated layouts. That's a long way in the future. And I think a solution like Pat Carone's with a camera would make a lot more sense at that point. Yeah, so that's what I'm working with at this point.
Do the rear wheels rotate at all, or are they fixed?
These ones at the back?
Yeah.
They are idle wheels. They turn freely. They simply don't touch
Oh,
the ground.
yeah. I didn't know how much show you were putting in there, you know, if you had them like rotate at a set rate or something.
I guess I could put a motor on them. Actually, my thought was they're really nice looking wheels and they're kind of soft rubber. They should come off and go into my spare wheel box for future use.
Yep.
Because they certainly don't serve any purpose on this device. I have two of these modules, two of these chassis, one with the electronics and one without the electronics. We'll see what I can turn the other one into. It may become my OpenBot chassis, right?
Oh, cool.
Yeah, we'll see. I'm building two of them together. So I mentioned I'm using an ESP8266. The reason being I have a bunch. I'm embarrassed to say I bought a bunch. I only used one on another project, and I thought I should find some way to use them. So this is, for me, this is kind of like a new microcomputer unit. Like the application I used the first one in is an MQTT bridge. And it's not my design. I just implemented somebody else's bridge. So I really didn't have to understand how it worked. Now I do. So it's been quite eye-opening. We'll come to that in a minute on the next page. I mentioned I've added an OLED monochrome display, 4 push buttons, 4 LEDs, and there's an 8574 I2C I/O expander. And this whole thing runs at 3.3 volts, simply because all the microcomputers these days run at that speed. Now, the 8266 only has a single analog input, and I need more analog inputs than that, so I've added an 8-channel analog multiplexer, just a 4055, a standard CMOS part. That's on that breakout board I showed you earlier. I'm using an L298N H-bridge because I have one. The batteries, I always put fuses and switches and resistor dividers on batteries so I can measure the voltage and have some modicum of protection. One can always debate how good a fuse is, but at least it will keep a fire from starting. There's 5 volts available from the expansion board I'm using, which has the Node MCU device on it. And there's also a 5 volt regulator on the L298N. I'm not using 5 volts yet, but I've made both of those available on my expansion board, my breakout board, just in case I decide to put a servo. So there's lots of 5 volt power here, along with a reasonable amount of 3.3 volt power. I have 2 different form factors of my 8266s. I have a bunch of these, a standard 30-pin breakout board, and I have some of these. These are WeMOS D1 minis. At first I thought, well, these are pretty tiny. You must not have very many pins. But I'll show you in a minute that that's not a limitation when you choose to use an 8266 for something. So that's the kind of stuff I'm working with. Now, a bit of the insight into what I'm learning as I work with these 8266s. I use I2C a lot, and ESP 8266s do not have any I2C hardware, unfortunately. They have firmware, and that's not bad. Some reports I've read in the forums indicate you might get 450 kilohertz I2C clock rates out of it. I normally run at a default 100 kilohertz, so that shouldn't be a problem. There are hardware UARTs on the 8266. There's 1.5 of them. One of them is used for the USB interface, so that leaves a half of a UART, which I will not be using. But most people suggest you can use it if you are attempting to output a log of activity, but I won't use it for anything. It'll just be a spare I/O pin. Pulse width modulation is really important when you're running motors. These things do not have pulse width modulation hardware. They have firmware. Most reports indicate you can connect the pulse width modulation firmware to any of the available I/O pins. There's been a few suggestions that only 4 pins actually work. I have not tested this yet. We'll see what happens. The firmware allows you to select pulse width modulation clock rates in this range. The 8266 is really strong on SPI. It's got 2 SPI hardware interfaces. And one of them is used to interface to the PSRAM, which is pretty important stuff, so you don't want to disconnect it. The other one is available. I simply don't have a use for it. So I don't know what I do with the SPI interface on this particular robot. So we'll see what happens, but it means the pins are available for general purpose IO uses. It also has one hardware I2S interface, very high speed serial interface. Again, I don't have a use for it, but it's kind of nice, I guess, to know it's there. More typically, I2S is used for high speed audio, digital audio stuff. I'm not sure what I would use it for. Now, the GPIO, very, very common and important stuff. Lots of the marketing stuff will tell you there are 17 pins available. There are not, because 6 of them are used to interface to the PSRAM, which you kind of need. So that leaves you 11. Of the 11, a few of them have limitations in what you can do with them. So right now I'm planning on using 9, and we'll see how well that goes. That's not very many IO pins. If somebody is offering you 8266s, you might not want to not bother with them. But I've got them, so I'll see what I can do with them. There is only one analog to digital converter input, and I've added an 8-channel mux to that. The downside of that, of course, is I need IO pins to control the mux. These things by default run at 80 megahertz, but they do run at 160. So I'll run it at 160 megahertz. There's only one CPU. There is some really, really nice Wi-Fi stuff, of course, that comes with this. It's not Bluetooth enabled, but it does run Wi-Fi. But you've only got one CPU to run all this stuff on. So if you turn on the Wi-Fi, then you'll find that you are going to lose an awful lot of CPU cycles in terms of the application you want to run on it. So I will not run this with Wi-Fi until I gain a little bit more comfort level with this stuff. I'm using the Arduino development environment, and the way the Arduino development environment for 8266s operates is it basically uses the Arduino C++ loop function, the place where you place all your code. It simply says every time you loop through that, it frees up time to run the Wi-Fi logic, which poses a whole lot of limitations in terms of what you place inside that loop function and how well your Wi-Fi will run and how well the rest of your logic will run. So if you were to choose to use these for Wi-Fi, then you need to think carefully about what the rest of your code will look like. Also, having been using lots of other embedded systems with a lot more power, I have stopped worrying about how much RAM and how much program space I have on these things. But it turns out you might have to worry about that again if you use an 8266. 32 kbytes of instruction RAM and another 32 kbytes of instruction cache RAM, which I think is what's used to flop code in from the PSRAM as your application grows bigger than 32K. I don't know yet what the implications are of this relatively small instruction RAM space. Now, I'm used to running on 8-bit Arduinos for a long, long time, but that's the same size as this. So I was kind of surprised to discover that this seems to be fairly small. So we'll see how this turns out. There is 80 kbytes of user data RAM, and that's kind of nice to see. Plus, you can use the PSRAM for a simple file system as well. Now, as I'm developing a lot of function blocks to run the application I want. I've done an architectural design, so now I'm filling in the pieces and writing code or looking for Arduino drivers in Arduino libraries that I like and that I think are well done. Or I write my own code. So I'm learning a bunch of this stuff. One of the concerns that came up was the fact that there's no floating point hardware on an 8266. And when you read through some of the forum references, people make a lot of noise about how awful this is. But finally, I ran across a thread where somebody did some real testing of the floating point operations, which are firmware based. In my opinion, they're fast enough. If you run the CPU at 160 megahertz, you can execute a floating point multiply in 450 nanoseconds. And a floating point divide for the samples I did were only about 375 nanoseconds. So frankly, I'm not worried about floating point. This is not a floating point intensive application. So I'm not worried about that. But there is no floating point hardware. So that's where I'm at now. I don't have any motors turning yet, but I've developed a lot of blocks of code, which soon will allow me to put together this stuff and see what happens. So that's as far as I've gone. Like I said, if somebody offers you 8266s, or as they're often known, an ESP12F or 12E, they work. I mean, they're better than a 8-bit Arduino, but they're not better than a whole lot of other choices at the same price points. So we'll just see how well I can use these things up. Go ahead. That's all I have. It'll be an interesting experiment.
Some projects.
Well, we'll see. We'll see. It's a line follower. It's not a complicated problem, I hope.
All right.
Tom, have you had a look at the courses to see which one you would like to run?
No, I have not. So
I was thinking of doing the advanced course, not the challenge course. Let me see if I share.
Pat, I'm working on this course.
I do the same. So if I share this guy, and so there was the simple course, the novice course.
Yep.
Which I think would be pretty simplistic to do.
Yep, I could try that.
You could try that?
Yeah.
So I was thinking of trying this one.
Okay. A little more logic I better think about.
So, but I'm probably going to lay out the courses on paper anyway, and just have them so we can, pick one and run it. Just take a bunch of pieces of paper together and some black paint, and that's what we're going to run on. You did want to give this one a try.
I have a bunch of these sheets, which are from the dollar store. So I was going to do my trial courses on these things. They're about, I think they're about 2 feet by 30 inches or something. Or they're
okay.
It's just foam board.
Just foam board, hard plastic with a foam core.
Yeah.
How much are they a piece at your dollar store?
Well, I paid $1.25 for them, but I bought them a few years ago.
Okay.
They might be coming from China. So, of course, we're not paying tariffs on China, are we?
We are. Yeah, I was going to say, I don't know where black electrical tape is made. Do you have like a DuPont company up there or something?
Well,
and I might have to buy some.
3M is made in, I think, the USA.
Probably, yeah.
And then there's all sorts of other stuff that's made by the cheapest seller. And like you say, you can tell that when you can tell when you get a roll of Chinese electrical tape, because you peel off about 3 feet and it's cut. And then you have to find the edge and peel off till your next random spot where it's cut.
Yeah, I have a lot of green painter's tape, and I tried that because I got so much of it, but it doesn't work. It doesn't look like black at all, and it looks just like white paper.
Oh,
that's surprising.
That's why I was thinking of using paint, because if I use it on paper, it's easy to put down. If I could find some tiles like that, but it takes quite a few tiles to make a course as well. If you're making whatever 6 feet wide by 8 or 9 feet long.
Yeah. So have a look at those pieces of foam board.
I'll take a look at the dollar store and see if I can. We've got a couple in town here. Maybe I can clean them all out, and then make a design. 2 different sides. Make a design.
I was gonna say, I'm wondering if you could take like a king size bed sheet and tape that up, and then when you're not using it, you just roll it up.
Put it back on the bed.
Yeah, you could, I suppose. Yeah.
Just like your local quilt making group and say, I want the quilt that looks like this.
There you go. There you go.
My wife makes quilts. I should ask her for one. I want one side like the advanced and one side like the challenge.
There you go. You know.
All right. Did anyone come across any interesting news during the week that's robot related?
I was intrigued to discover that apparently one of the leading full-size vehicle auto navigation software development companies is based here in Toronto, called Waboo, if I remember correctly. Have you run across it before? There was a video interview on CBC last week with their CEO. They've been doing development work for about the last 10 years here and have signed a major contract with some US company for rolling out autonomous navigation systems on transport trucks. Apparently a very, very big contract.
That's a big deal.
Yeah. I should look them up, see if I can find them again.
Probably beats, truckers that drive way too long and take drugs to stay awake. And I think I'd rather rely on an autonomous truck than.
Oh, it's Roby's head.
Yeah, so my job is to get it to be less rickety.
Did you have any ideas yet, Mike?
Duct tape. No.
White duct tape.
I haven't thought about it yet, but I can make it better.
Poor thing looks like it was abused.
I do have some white duct tape if it comes down to it.
Oh wow! Didn't know they made white duct tape.
I like the idea of having panels with magnets on the corner, so we can just like pop it onto.
Ooh, I like the magnet idea.
Oh, I like that idea.
Yeah,
it seems better than Velcro, maybe.
Yeah,
got lots of magnets if we need magnets.
Yeah, it's going to say if they're the rare earth ones, those can generate a fair amount of force. Yeah.
Yeah, and likewise on the hand, I'm still trying to come up with a good solution for round rod, round hole, securing it, but then being able to take it off. Yeah. Some thinking to do, some designing, some prototyping.
Roby will thank you.
Are we going to hook up the other hand to the code? Because right now the other hand is on the servo tester. You're thinking about like maybe are we going to run that to the Mega as well? Because the left hand's fixed, but we can control the wrist with the Mega. But with the right arm that moves, it was just attached to that servo tester, right? So do we want to try and hook it up? I don't know. Thinking out loud.
I don't have a vision for it. I just want it to be like useful again. That's the extent of my personal aspirations for it.
I guess someone has to come up with, can you recompile the software and have it run again?
Yes.
Yes. I will take that on. But it comes with risks.
But the bad thing is, like, can you suck the software or the code out of an Arduino and save it? Or do you just have to override it?
I've never seen it, but not that I've seen, no.
Yeah.
No, with the right tool, well, regular Arduino probably not, unless you have some sort of if you have one that has a sort of a JTAG or some other Atmel specific, debug interface. So if it's a non-Atmel like a JTAG, then you can pull it out with the right tools.
Yeah, that's the danger for Roby is if you don't have the software right and you override it, then it's bricked.
Yeah.
Yeah, I don't know if you guys noticed, but he's only got 2 fingers on the one hand that he brings up, so that that could be interpreted as a bad thing in certain countries,
Oh, I know what you could do. You could, I mean, the Megas are pretty cheap for the Arduino Mega, so just replace the motherboard and have the other one on the side to put back in if you can't get the software working. That way, instead of using the same board, just change the board out. Yeah.
So the libraries that were in the GitHub, they aren't the ones that are on the Mega?
I assume they are.
They're supposed to be. That's what Doug said.
I feel like they are.
Yeah. But I would take the board out and say, okay, this is the backup, and then get a new board in there.
Yeah,
That's true. That would be. Does anyone have an AT Mega?
Yeah, I got one.
Ah.
I've been playing with it with the code, so.
Okay.
Oh. So
that way you wouldn't be overriding the stuff that we know works. And
that's
Right,
a good
right.
idea. That's of course you could just be brave and try it.
I'm for it.
So that's interesting, Mark. Because then if you did that, if we used that, we just have to transfer all the connectors over and make sure we got them right.
Right. Yeah, I was thinking of making, because I'd like to have like the schematics as to what it is right now, like what goes to where. That would be important.
Yeah. Doug said he thought he had a wiring diagram of it somewhere, but
that would help.
things like that can be difficult to find.
It shouldn't be too bad to draw up.
No.
Yeah. So.
Use Tiki CAD. Yeah.
Tiki CAD?
Huh?
I don't think I've used Tiki CAD. Tiki CAD.
What was the name of that program?
Oh, PCAD.
PCAD.
Oh,
PCAD.
PCAD. Yeah. There we go.
Tiki. Yeah. PCAD.
Yeah. It's a thought. It's a good thought. Get some good practice with that tool.
Yeah.
Mm-hmm. Let's see.
All right.
Yeah.
Well, anything else? I feel like we're losing steam here.
I don't know. What are you doing Friday evening, Paul?
I don't.
Any plans? You want to do some schematic drawing? Get together?
Yeah, that'd be all right. Let me just check my calendar. All right. I'll put you on my calendar, Mark.
All righty.
All right. Thanks, Paul.
Yep.
Okay. We will figure out a time offline.
Yep. Sounds good.
All right. If no one's got anything else, going once, going twice, going three. Good night, everyone.
All right. Good night.
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 Thank you.